Welcome to the General Chemistry 2 class. This section is on electrochemistry. This lesson is about cell potential of a galvanic cell. Let's begin. In this lesson, we will relate the value of the cell potential to the feasibility of using the cell to generate an electric current. Recall, galvanic cells can be used in redox reactions that occur spontaneously. For a reaction to be spontaneous, the Gibbs free energy of reaction must be negative. The Gibbs free energy of a redox reaction is an electrochemical cell is related to the cell potential according to the equation. Gibbs free energy of reaction equals to the negative of the number of electrons involved in the redox reaction times the Faraday's constant, which is equal to 96,485 coulomb per mole, times the cell potential in volts or joule per coulomb. Given that the Gibbs free energy of reaction is negative for a spontaneous reaction, the cell potential must be positive, since the Gibbs free energy of reaction is positive for a non-spontaneous reaction. The cell potential must be negative. If an electrochemical cell has cell potential greater than zero, flow of electrons can occur spontaneously. An electric current can be generated. This is the value of cell potential that must be met by a galvanic cell for it to work. Remember that in a previous lesson, we learned that in measuring the standard reduction or oxidation potential of a half cell reaction, the half reaction of interest is paired with a standard hydrogen electrode in a way that galvanic cell can be created. The requirement of above zero cell potential for a galvanic cell explains why the standard cell potential, or SHE, is the cathode when paired with some anodes, like the zinc electrode, and becomes the anode when paired with cathodes, like the copper electrode. The Daniell cell has standard reduction potentials of 1.10 volts. Since the cell potential is greater than zero, the cell will work as a galvanic cell. The copper-silver cell has a standard reduction potentials of 1.14 volts. Since the cell potential is greater than zero, the cell will work as a galvanic cell. Example number 1. Determine whether a galvanic cell can be made for the following reaction. Solution. Calculate the standard cell potential from the given standard reduction values. Note that we must reverse the sign of the standard reduction potential for nickel to nickel 2 ion, since the process is oxidation. Adding the electrode potentials, positive 0.25 volts plus negative 0.74 volts, we get a standard cell potential equal to negative 0.49 volts. Since the standard cell potential is less than zero, then a galvanic cell cannot be made for the reaction. To summarize, the value of the cell potential of a galvanic cell must be positive to allow flow of electric current. Thank you. Welcome to the General Chemistry 2 class. Welcome. Psst, psst. Welcome to the General Chemistry 2 class. This quiz is about cell potential of a galvanic cell. Let's begin. Number 1. Number 2. Number 3. Number 4. Number 5. Number 6. Number 7. Number 8. Number 9. And number 10. Time's up.